Welcome to section 7.6. We're going to be using all that we know about exponentials and logs to help us solve equations. So all of the work we've done in chapter 7 is to get ourselves to this point. We're starting in numbers 1 and 2 with what we call the one-to-one property. And this is going to come up, and the whole goal is to be able to cancel things off on both sides as we go through. So take a look. First of all, we like the fraction the least in number 1. So I'm going to rewrite my fraction with an exponent. 1/2 is the same thing as 2 to the negative first power. And I'm going to write it this way because I like a base of 2 better than I like a base of 1/2. Now, if I rewrote this side with a base of 2, I'm going to try and rewrite 4 with a base of 2 also. Well, 4 is the same thing as 2 squared. And I have that then to the x power that was there. Now, what do I do with the exponents? I multiply them. So 2 to the 2x equals, and here I've got to distribute the negative 1, 2 to the negative x, and negative 1 and negative 3 makes plus 3. Now, according to the one-to-one property, and this is why we do this, if their bases are the same, then I can cancel them out because then their exponents must be equal. So I have 2x equals negative x plus 3. You can only cancel bases if they are the same number, or you can make them the same number. Okay, so take a look. Now that I have the bases gone, I'm just going to solve an equation. 3x equals 3. So I divide by 3, x equals 1. Okay, and so this is the idea of the one-to-one property. Now we're going to try this again in number 2 and kind of make sure that we're getting the idea. Now I always start with the fraction because the fraction's the worst part. 1/3 is the same thing as 3 to the negative 1 power. And since I have this 5x minus 6, I just have to include that as well. Now, because this is a base of 3, I need to make 81 a base of 3. Now, through all we've done in exponents, we kind of expect that you know that 3 to the 4th is 81. Now I have this 3 minus x there still. Okay, so what I'm going to do is distribute my exponents. 12 minus 4x. Sorry, oops, not 2, 3. Let me erase that a second. It's a base of 3. So 3 to the 12 minus 4x equals 3 to the negative 5x plus 6. So I distributed the negative 1, I distributed the 4. Now that the bases are the same, I can cancel them. So 12 minus 4x equals negative 5x plus 6. I'm going to move the 5x, and if I move the 5x to this side, if I move the 5x to the left, then the 12 has to go to the right. Negative 4 plus 5 is an x, is 1x. 6 minus 12 is negative 6, so x equals negative 6. Okay, so the idea of the one-to-one property is that you can make the bases the same. My suggestion is start with rewriting the fraction. Okay, that's my first suggestion, because if you rewrite the fraction, then it'll tell you what the base is on the other side. So that's the one-to-one property. The second side is going to not have the same two sides be the same, so we're going to have to rework this a little bit. Okay? Number 3 says 4 to the x equals 11. Now I know that 4 to the first is 4, 4 to the second is 16. So the question is, my answer is going to be between 1 and 2, but it's not going to be an exact number. Now, to get rid of an exponential, we're going to have to go to a log. Okay, so what I'm going to do, because this base is 4, I'm going to say the log base 4 of this side, and I'm going to say the log base 4 of this side. So what ends up happening is I have the log base 4 of 4 to the x equals the log base 4 of 11. Now, why did I choose base 4? Because 4 was the base of my exponent already, And according to the properties we learned yesterday, the log base 4 will cancel with the 4 that's already there. So I have x equals log base 4 of 11. Now the problem is our calculators won't give us an answer for this, so we're using the property we learned yesterday as well, the change of base. The log of 11 over the log of 4, and that's going to get us in a decimal approximation. Now we said in the beginning we know it's between 1 and 2, so what do we get? Let's go 2 decimal places, about 1.73. And you want to use this approximately symbol because it's not an exact answer. We rounded a decimal. Okay, now let me walk you through another one. I'm just going to make it a little bit more difficult kind of as we go through. We need base e by itself. So I'm going to add 7 first. 4 times e to the negative 0.3x equals 20. So I moved the 7 over. My second step is to get rid of the 4 in front. So I divide both sides by 4, which cancels those 4s out. E to the negative 0.3x equals 5. Now that I have a base to an exponent by itself, now I have to get rid of the base. Well, my base is a base e, so what log can I use that has a base e? That's a natural log, which has a base e, so I'm going to natural log this side. The natural log cancels with the e to get negative 0.3x equals the natural log of 5. Now I'm going to wait to do that one in my calculator until I'm done. How do you get x by itself? Divide by negative 0.3. And now I'm going to say approximately because I'm going to get a decimal. In your calculators, take the natural log of 5 and then divide it by negative 0.3, and you should get about negative 5.36. And again, I'm going to round to 2 decimal places because I think that's the easiest. So we're solving equations. Once you get to an exponential and you don't know what to do, we're going to log that base. Okay, now we're going to practice tomorrow some more in class. I'm just going to kind of give you the basics. So that's the second idea, where you have an exponential and you have to basically log both sides. The third type already starts with logs. And so I want you to look at this. This actually is another version of the one-to-one property where it says the bases are the same, you can cancel. Well, take a look. I have a log base 5 on this side equal to a log base 5 on that side. Because the bases are the same, I can cancel the logs. So what I have then is 4x minus 7 equals x plus 5. All right, let's start solving. I'm going to move an x over, and if I move an x to the left, I have to move the 7 to the right. So I have 3x equals 12. And if you need to take this in 2 steps, you can. By this point in time, though, we kind of expect that you understand why I'm taking it in 1. Divide this by 3, I get that x is 4. Here's the only problem. When you start with logs, you have to check your answer. Check your answer with logs. Okay? Only when you start with logs. Because here's the biggest thing. You cannot, I'll put it down here, you cannot log a negative number. Remember when we did our graphs, our logs never had negative numbers in our domain. So that's this idea. You cannot log a negative number. So all I want to do is check. If I put a 4 into this left one, 4 times 4 is 16 minus 7, I get the log of 9, log base 5 of 9. On this side, if I put in a 4, I still get the log base 5 of 9. And because this 9 is positive, I'm going to circle this answer. Even if these 2 answers were the same, as long as this number, if this number is negative, you can't do it. Okay? And I'll talk about that on the back side. Take a look at 6. Again, the logs are the same on either side, so I can cancel them. So I have 7x minus 4 equals 2x plus 11. Again, I'm going to move things. I'm going to subtract a 2x and move it to the left, which means I'm going to move 4 by adding it over to the right. 5x equals 15. So when I divide by 5, x equals 3. Oh, I circled it and I shouldn't have. I apologize because we didn't check. Let's double check just to make sure I was supposed to circle it. 3 times 7 is 21, minus 4 is 17. That's a positive, so that's good. Let's make sure we get the same number and it's positive 17 on the other side. 2 times 3 is 6, plus 11 is 17. Good, it's both positive and the numbers are the same, so x equals 3 is a solution. And again, I'm sorry I preemptively circled that, but you do want to check as you're going through. So this gives us 6 questions. We're going to try a couple more on the back just to make sure that we've got this idea of working with logs. So if you flip to the back side, we're down to the last 2, and I love these 2. Oh, I'm sorry, we've got 4. These top 2 I really like because they make you use your exponent rules from earlier, or I'm sorry, your log rules. So look at this. If I have 2 logs on the same side, I have to combine them using my log properties. Well, addition of logs means you multiply their numbers. So 5x times x minus 1 equals 3. Now, you can distribute that first if you want. Oh, I'm sorry, it doesn't equal 3, it equals 2. You can distribute that first if you want. I'm going to wait a second. Now, the problem is I can't get inside my log until I get rid of the actual log itself. And this log has a base 10. So how do I get rid of a log base 10? I need a power with a base of 10. And so we call this exponentiating. I'm going to take 10 and make this my exponent. And I'm going to take 10 on this side and make 2 my exponent. Because what it does is 10 cancels with the log base 10. And now I'm going to distribute. I have 5x squared minus 5x equals 10 to the second power is 100. Because I have both an x squared and an x, I need to set this equal to 0. So I have 5x squared minus 5x minus 100 equals 0. And I'm going to factor. I can take a 5 out, x squared minus x minus 20. And I'm going to factor this. X and x makes x squared. 5 and 4 makes 20. But the 5 has to be negative in order to get a negative 1x. So I have factored x minus 5 and an x plus 4 equals 0. Now, according to what we did in part A, this means that x is 5, because it's always the opposite. This means that x is negative 4. And before I can circle these, because I started with a log, I need to plug them back in and make sure I don't get negative logs. If I plug in a 5, 5 times 5 is 25, so I get a positive number. 5 minus 1 is 4, that's a positive number. Because they're both positive, 5 is going to work out. Okay? If I plug in a negative 4, 5 times negative 4 is negative 20. I can't take the log of a negative number, so this is what we call an extraneous solution. Because we got it when we factored, but when we plug it back in, it doesn't work since I can't take the log of a negative number. So let's try one more like that, because this is the hardest type, I think, of all of the logs. Okay, so 8. Again, 2 logs on one side means combine. And because it's it's an addition, I know I gotta multiply. Now in this case, I'm gonna actually multiply them to start. This x is gonna go to both. So x squared plus 12x equals 3. And now what's the base of my log? This is a base 4. So to get rid of a log base 4, I'm gonna take 4 to this side and 4 to that side. because then the 4 and the log base 4 will cancel out. So x squared plus 12x equals 4 cubed is 64. I move the 64 over, so the process is still the same, it's just going to be different numbers. X squared plus 12x minus 64 equals 0. Now, how do you get 64? Okay, you can start listing out all the factors. To save us time, I'm going to tell you that it's 4 and 16. Now, which one's negative? The 12 has to be positive, so the bigger number's positive, so it's a negative 4. So x minus 4 and an x plus 16 equals 0. This first factor tells us that x is 4. The second factor tells us that x is negative 16. Plug it back in. If I plug a 4 in, 4 plus 12 is a positive number, that's okay. If I plug a 4 in, it's a positive number, that's okay. If I plug a negative 16 in, I already get a negative log here, plus I get a negative log here, so this can't work. There's our extraneous solution. So the only answer we have for this one is x equals 4. Now I've shown you 2 of them where you have extraneous solutions. You won't always have extraneous solutions, or they both could not work, and then you would say no solution if they both don't work. Okay, so that's the idea going forward. Let's try the last 2, and then we'll be done for the last section in chapter 7. All right, take a look. I got to get the log by itself. So my goal is to get this by itself. So I'm going to subtract 3 first. 4 times the natural log of negative x equals 21 minus 3 is 18. All right, we got to get rid of the 4 in front, so to do that we divide. So the natural log of negative x equals, now I'm going to divide this. 18 divided by 4 is the same thing as 9 over 2. Because it's a nice decimal of 4.5, I'll let you keep it in decimal form. Most of the time, though, you should get used to keeping it in a fraction. Okay? Now, what's the base? I'm stuck here in a log and I can't get to x. The base of a natural log is e. So how do you get rid of a log? You raise this to the e to this side and e to that side so that my logs will cancel out. So I have that negative x equals e to the 4.5, and I don't want a negative x, so I divide by negative 1. Actually, let me get rid of this. I want x. X is approximately negative 90.02. Now, before I circle this, I need to make sure it works. Normally, we say we can't have the log of a negative number, but you'll notice, what is x? X is a negative. So the opposite of a negative is a positive. That gets me a positive log, so that one will work. Okay, and that's kind of a different one, but we wanted to at least show it to you. Number 10 is a one-to-one property because they're both log base 5, which means they cancel. 2x minus 7 equals 3x minus 9. I'm going to move the 2x to the right, which means I got to move the 9 to the left. Negative 7 plus 9 is 2. 3x minus 2x is 1x. All right, so I look at this and I say x is 2. Now, before I do anything, I better check it because I started with a log equation. So 2 times 2 is 4. 4 minus 7, oh no, it's a negative number. So I say no solution because, again, I can't take the log of a negative number. Okay, so that's section 7.6. Again, it's all about using our log properties and canceling things out and rewriting as we go through. So be ready. We're going to practice this. You'll have a warm-up on your way in to practice. But make sure if you have questions, write them down, kind of circle them, star them, what if, things like that. Okay?